So, good morning class. Today we will discuss about solid state, which is our next chapter of physical chemistry. So, when we are discussing about solids or when we are discussing about solid state, so when we are discussing about solid or when we are discussing about solid state, so we are aware of some of the physical, some of the basic properties of solids. So, we are not going to discuss all those points again, like what are the properties which solid have, high molecular forces, high molecular strength, density and other properties. But we will see different types of solids, we will discuss about unit cell, we will discuss about different types of packing, different types of voids, and after that at last we will see the imperfections or defects which are developed in solids. So, these will be our course of different topics which we will discuss in this chapter. So, let us discuss from the first topic. So, basically let us see the classification of solids. So, basically let us see classification of solids. So, basically solids can be classified into two categories. They are crystalline solids and the other are amorphous solids. So, basically they are of two types, crystalline solids and amorphous solids. So, let us see what are the different further classification of crystalline solids. So, these crystalline solids can be divided into further four categories. These can be divided into further four categories. So, the first one is ionic solids, the second one is covalent solids, molecular solids and metallic solids. So, these are the four types of solids which can be categorized as further types of crystalline solids. So, crystalline solids are of further four types: ionic solids, covalent solids, molecular solids and metallic solids. So, when we are discussing about ionic solids, this means that they are made up of ions, that is positively charged cations and negatively charged anions. When we are discussing about covalent solids, this means that they are made up of non-metals having mutual formation of covalent bonds, sharing of electrons. The third one is molecular solids, which are made up of molecules, like we will see the case of dry water, the CO2, condition of CO2, and the fourth one is metallic solids. So, these are the further classification of crystalline solids, and covalent solids are also known as network solids. So, they are also known as network solids. So, this is overall the case, the classification of solids. So, now let us discuss the two types of solids in detail. So, let us see the first type of solid, that is crystalline solid, that is crystalline solids. So, when we are discussing about crystalline solids, so these crystalline solids have some general properties or general characteristics, and let us see those characteristic features. So, some of the features are like first one, it has long range order, it has long range order. The second point is it is anisotropic, and the meaning of anisotropic is different values of physical properties at different points. The third one is sharp cut. They can be sharp cut with a knife, and the two parts we will get after cutting the crystalline solids will be identical in shape. Both the solids which will be obtained by cutting that particular crystalline solid, and the two halves which are obtained will be totally identical in shape to each other. And the fourth point is they have fixed values of physical properties. And what are the physical properties? Let us see some of the physical properties, like for example melting point, boiling point, refractive index, viscosity, surface tension, etc. So, these are some of the important features of crystalline solids, and one more point can be added to this. These are true solids. So, these are some of the important features of crystalline solids. So, the first one is they have long range order. The meaning of long range order is when we know that the crystalline solids or solids, any solid is made up of small amount of unit parts, the elementary parts which are called unit cells. And if we are arranging the unit cell in a definite pattern, and after arrangement we are able to get the entire crystal or the entire solid, then that solid is said to possess long range order. The next point is anisotropy or anisotropic. Anisotropy or anisotropic means that if this is our solid, because solid is three-dimensional structure, so we are representing it with a cube, because cube is the three-dimensional portion of square and two-dimensional arrangement will be square. So, if we move from any point to the other side, from any one point to the other side, and if the values of physical properties is different at different points, then it is said to be anisotropic in nature, and crystalline solids are anisotropic in nature. The third point is they can be cut with a sharp knife, and after cutting the two parts which are obtained will be identical in shape. Fourth point, they have fixed values or definite values of physical properties, different physical properties like melting point, boiling point, refractive index, viscosity, surface tension, etc. And the last point is true solids. Crystalline solids are regarded as true solids, whereas when we will discuss about the case with amorphous solids, those are false solids or not true solids because of certain reasons that we will discuss later, but these are the general characteristic features of crystalline solids. So, let us see one more time what is the meaning of long range order and anisotropic. So, long range order means that if we are arranging the unit cell if in a definite manner, and after arrangement we are able to get the entire crystal, the entire solid, then that solid is said to possess long range order. And anisotropic means that if we have a solid like this, let it be a solid. So, when we are moving from any one side to the other side, and if the values of physical properties are different at different locations, then that crystal is said to be anisotropic in nature, and crystalline solids are always anisotropic in nature. Now, let us see the characteristic features of amorphous solids. So, these were all about crystalline solids. Now let us see some of the characteristic features of amorphous solids. So the second type of solids are amorphous solid. So let us see some of the characteristic features of amorphous solids. So these are just opposite of crystalline solids, and the characteristic features will also be different. So they had long range order, but amorphous solids have short range order. The second point is they were anisotropic in nature and they are isotropic in nature. And isotropic in nature, this means that the values of physical properties are same at all the points, everywhere they are same. Now the next point, no sharp cut is obtained, they can't be cut sharply with a knife or any other instrument. They do not have definite value of physical properties. They do not have definite value of physical properties. And what are the different physical properties? For example, the properties are again the same: melting point, boiling point, refractive index, viscosity, surface tension, etc. So these are some of the examples of physical properties whose values are not definite for case of amorphous solids. And the last but not the least point is that amorphous solids are also called pseudo solids, that is false solids, or they are also called supercooled liquids. They are also called supercooled liquids. Because they are called supercooled liquid because these have tendency to flow. So that's why we know that solids can't flow, but here they had been seen to flow. That's why they are regarded to be pseudo solids or false solids. Let us see some of the examples of amorphous solids. Some of the examples are like glass, rubber, mica, quartz, etc. These are the examples of amorphous solids. So these are some of the general features of amorphous solids. So the first one is short range order, means if we arrange the unit cells in a different arrangement, we are not able to get the entire crystal, the entire solid, and this is meant by short range order. These solids are isotropic in nature, means the values of different physical properties are constant, are definite at different points of the solid. The third point is there is no sharp cut obtained when cutting or when the amorphous solids are cut. The two shapes which are obtained are not sharp points, not identical. The next point is we do not have definite value of physical properties like melting point, boiling point, refractive index, viscosity, surface tension, etc. And the last point is amorphous solids are also called pseudo solids. Pseudo means false, that is they are not true solids. And why they are called pseudo solids? Because they are also known as supercooled liquids, because as we know that solids can't flow, but amorphous solids had been seen to flow, they have a tendency to flow, and hence amorphous solids are also regarded as supercooled liquids. And some of the examples of amorphous solids are glass, rubber, mica, quartz, etc. So, these are the different examples of amorphous solids. Now, let us see a case where we can prove that amorphous solids are supercooled liquids. Let us see a case. So, we must have observed that in case of old window panes, so let it be old window pane, like we have in case of old houses, we have old window panes, old glass window panes. So, we must have observed that the panes, the glasses are thicker at the bottom. So, they are thicker at the bottom and relatively they are thinner at the upper portions. So, we must have observed in case of old houses that these glass window panes are thicker at the bottom portion while they are thinner at the upper portion. The reason behind this is that due to excessive heating, due to regular heating, this glass has attained its melting point, and after melting, since glass is a solid, after melting it will be converted into liquid, and once the glass is converted into liquid, due to the action of gravity, it will gradually flow downward. And due to regular flow, it has collected near the lower portion, near the downward portion, and that is why these old window panes are thicker at the bottom and they are thinner at the top. Comparatively, they are thinner at the top, and since in this case they are flowing, they have fluidity, and which is against the properties of solids. That is why glass, being an example of amorphous solid, has been regarded as pseudo solid, false solid, or they are also regarded as supercooled liquids. So, thank you class.